welcome to my channel. I know it's been a long time since I posted a video, but don't worry guys, I'm coming to you with yet another sweet and fun tutorial. And in this tutorial we are going to be looking at ArcGIS scripting with Python. So we'll be looking at an introduction to some geoprocessing using Python, exploring spatial data, manipulating this data, also using SQL in Python, working with geometry also in the data, and converting the script that we create into a shareable tool. As you can see, we'll be using Jupyter Lab, and Jupyter Lab enables us code with narrative texts, equations, visualizations such as maps, and interactive consoles. So it uses in ArcGIS scripting, we'll be using ArcPy, which is a site package, and it bundles together all the modules, and the modules are just a bundle of functionality that we are going to use. So let us start by importing ArcPy. And before you can import ArcPy, I just want to mention that you have to connect Jupyter Lab to ArcGIS. And I have a blog that I have written. I linked the link in the description box below. That is the box that is just right at the bottom. I'll link the procedure so that you can follow it before you get started. Otherwise, you can use any other editor that you like, but I prefer using the Jupyter so that I can run my codes line by line as I check for any errors. We'll start by importing ArcPy, and just type import ArcPy, which is very simple. Then we'll also need to import env from the ArcPy site package. So env will be used to specify our workspace. We can use it to overwrite the files. So for now we'll just use it to specify our workspace location. So env from ArcPy import env. Then you can just run that up. As easy as that. Next, we are going to define our workspace, and this is where we'll be working on. A workspace can either be a folder or a geodatabase. And if we further split a geodatabase, it can be either a personal geodatabase, which is in the form of MDB, or file geodatabase, which is the form of GDB. So in our case, we'll be using a folder for our first case. And I'll just paste it there so you can run it. As you can see, my workspace is in this folder, exercise 8. Next, we'll be looking at geoprocessing, and that is in terms of the tools that you can use. There are several tools that you can use: buffer tools, clip tools, you can use project tools. There are several tools in ArcToolbox. We'll just look at one example, and I will use the buffer analysis tool. So let me just show you an example of how you can go about that. You'll just use ArcPy dot. Now within ArcPy we have the buffer tool, and we have it under analysis. So analysis is the alias or the alias. Then buffer is the tool. So now the buffer tool takes in several arguments or parameters, and the mandatory parameters that it takes are the input feature class. It takes in also the output feature class, and then it takes in the distance. So I'll just specify that. This means that we need to first define which input feature class we are going to be using. So let me just comment that. Define workspace. Then define feature class. So easy. We'll just say FC is equals to, FC is the feature class. You can name it as you like. Reverse. buffer.shp. And one thing I'd really like to mention is that in our case, our workspace is a folder. This means that if we were to specify our feature class, we need to specify the type of extension of the feature class. As you can see, we have decided to specify it as .shp, and that is the way it is. If this was a geodatabase, that is MDB or GDB, then the only thing we'll need to do is just specify the name of the feature class, just like that. So we'll just go back to the way it was. So our input now is FC, you can just replace that. Then our output will be saved in the workspace. We can name it as river buffer. River buffer.shp. Then this one needs to be a string. So you need to have prior knowledge of programming using Python, at least the basics. Then now we have to give it the distance. So just you give it the distance and you give it the units. So I'll just be using meters in my case. So I want to buffer by 100 meters. Or let me reduce it to 50 meters. So that's about it. We can just run the process and see. We seem to have an error somewhere here, and it says there is invalid syntax. So as you can see, most of the time will be spent in debugging your code, and this is very normal. So you can see here we forgot to delete these rivers, and now we can run it. Great. So if you try to run this code again, it will give you an error trying to tell you that this file already exists. This means you are either going to delete this file or you are going to rename this output file, the buffer.shp. Okay, so let's go to ArcGIS and see a few things. Here is my workspace, and I've just added it as a folder connection. I'll add the rivers, then I'll add in the buffer.shp. Drag and drop it here. And as you can see, you have some pretty awesome stuff. These are the rivers, and they have been buffered by 100 meters. We can just add the rivers so that you can see them. Remember that the buffer is just a polygon type of feature. So let's add the rivers also to see. So if we zoom in, for example, to this, the rivers have been buffered by 50 meters, and this means that is 25 meters from the center line of the river. We can also check the buffer tool and how it works. We can check the documentation. This is very easy. You just go to search. Remember, it is important to document your tool so that it can help others who are going to be using your tool or for future reference. So if you scroll down, you have the buffer tool. You can read the rest, but you can see the parameters that it takes in: the input feature, the output feature class, then it takes also the distance as specified. Those are the mandatory or compulsory parameters that we need to supply. Now we have the optional parameters. We have the line side. You can either decide it's going to be buffered on the left, on the right, full, or outside only. Have the line end type, if it's going to be round or flat. In ours it seems to be round. Then the dissolve option. By default the line end type is round. Then the dissolve option, it specifies the dissolve to be performed, that is none, all, or least. Then finally we have the dissolve field and the method. Now if for example you want to specify the dissolve field, let us just go back. A dissolve field will take in Okay, let's look at something like the method. If you want to take in the method, it's either planar or geodesic. So you can, if we go back to our code, if we want to add the optional arguments, we cannot just go directly to the method. That is, we cannot just specify geodesic. This is because it will take the first optional parameter, and that means it will take the line side, and we don't want it to do that. So there are many ways that you can skip other optional parameters. One way is to put hash for every parameter that you are skipping, or to leave it as a space, or you can use the name of the option. For example, now the name of the option is a method. If you want to be very specific, then the method is planner. Then you can just remove that comma like that. Let's look at a situation where you want your code to be flexible. That is, you want to avoid hard coding. When I say hard coding, I mean you are putting this specific path, for example, the workspace. If you decide to share this final tool to someone else, it will mean that they have to have this path in their system. But since we want to make it dynamic so that the user inputs their own workspace, we'll need to make our code flexible. And there is a very easy way of making our code flexible, and we'll use the get parameter as text from the ArcGIS. So let me just show you. If you want to specify the workspace, you'll use ArcGIS dot get parameter. And the good thing about Jupyter Lab is that you can press tab for the autocomplete. So get parameter as text, then you're going to specify 0 for the first one. If you are going to if you need some other second user input, you will need to put it as get parameter as text 1. So for example, you want to specify the feature class, so that one will also be ArcGIS tab dot, and I'm just going to use tabs to help me out, get. So you can see it has the autocomplete functionality, which is very nice. Then you set it as 1. Then finally, let's say we are going to just perform buffering again. Let's say we want to perform buffering analysis. We'll just use ArcGIS dot buffer analysis. Then we'll set the feature class. We can also specify the output, and that is the output ArcGIS dot get parameter as text. Then that will be 2. Remember the indexing in then let's run this. So one thing I'd like to mention is that when you are working on your code, you are going to just hard code the paths, but now when you want to deploy your tool to ArcToolbox, you will have to change the paths to be dynamic. So since these paths are dynamic, we cannot test them here, but you can save this script and convert it into a tool in ArcGIS, and then we can now use it in ArcMap, and then we can now use it. So this is how you can just make your code flexible. Now let's say you're in a situation where you have an output of a buffer analysis and you want to use this output as an input of another tool. Remember that when I was showing you about the model builder, we were just using the output as the input of the next tool. So this will be the same way. You can go and check out the videos. I'll leave a link in the description box. I will also leave a link in the description box on how to create geodatabases on ArcCatalog and also to work with ArcCatalog. So we have performed buffer analysis on our rivers, but now let's say that we want to count the features that have been finally formed. So you can use the arcpy.getCount tool, which is under management. So for that, first you need to assign the buffer analysis a variable. You can just name it buffer like that, then run it. Then now you want to count. Now want to count, and you want to count the arcpy. I said it's get count management. It's under management alias. Let me just move that up. Then the name of the file is buffer. You can just rename this to buffer1 so that you can get rid of this error and run it. Then we'll just rename this to buffer like that. You can run it. Now if you want to, we'll also need to, apart from get count buffer, we need to .get the output, and we'll set it as 0. So run it. Now you can just print count. And we have 26 features that have been formed, so 26 buffer polygons. Next we'll look at working with third-party toolboxes. So we can import a toolbox and we can indicate where the toolbox is located or will be located. So that's pretty simple. Just specify arcpy dot, now use the import toolbox, then you specify the path of the toolbox. So I'll just look for one of my toolboxes. Next we are going to be working with licenses. There are various types of licenses. You can check them out on the ArcGIS site, and we can check if a license exists, and it can either return if it's available, that it's there, unavailable, it doesn't exist, not licensed just simply means it's not licensed, and failed means the license has failed. So let's just create a new notebook for that. I'll leave all the notebooks in a GitHub repository, and I'll link them in the description box. So just import arcpy, then run, and now specify the workspace. Actually we don't need to specify the workspace because you're just checking the license. So check license, and to check license use the check extension. As easy as that. Arcpy dot check extension function. So check extension, and we can check the spatial extension, for example the spatial, and then let's run and see our output. So as you can see, the spatial license or extension is not. You can use an if else for just checking the conditions, or you can use a try except finally or try except else statement for error handling. So we'll just use an if else. We'll use a try and except in a later video or in the later part of this video. So let's just use if else. So we want to check if, I'll just edit this part and say if ArcGIS dot check extension is, let's use 3D this time, 3D is equal, and you just use two equal signs, is equal to available then, sorry, you have to put the colon, then ArcGIS dot checkout extension. And what checkout extension does is it acquires the extension first. So checkout extension, then you're going to check out which extension, 3D. You can just specify the comment here. So acquire license. Acquire license. So you're just going to print "3D analyst is available." Then always remember to check in the extension, that is release the extension. So ArcGIS dot check in extension. It's just the 3D one. So in an organization whereby you have bought only the license for one user, then it means that you are going to be sharing these extensions. So if one of you has is using the 3D extension, that means no one else in the organization can use it. And for the other person to use it, it will mean that you have to release the extension, and to release it you just use check in extension. So this one will just release, you just put a comment, release extension. Then we'll just use an else statement to close it off. Else print 3D analyst is unavailable. So 3D analyst is unavailable. And just delete this and run. So as you can see, 3D analyst is unavailable. If it were available, then we'll be able to perform some functionalities such as, or processes such as slope, you see, to use the extension. Now we'll just set our feature class, and let's state it as rivers.shp. So to check if it exists, we'll just use ArcGIS.exist. So ArcGIS.exist, and it should return a boolean of either true or false. So the file is fc. Then let's run that. So it exists, that's true. Let's try another one where it does not exist. Let's change this to river. So in my folder, the whole folder, I don't have a file called river.shp. So let's run that up again. Sorry. And it should be false, meaning it does not exist. Then one more thing we can do is to describe the data. We can describe the data in terms of the data type, the data paths, the catalog, the file name, etc. So let me just show you can do that. Then now you can check the data type by using describe dot data type. That will give us shapefile describe dot data path. So that is the path. Just use the path, and you can see the whole path of the workspace. Then describe dot catalog path, and this one now gives us the path to where the file is. And then you have describe dot file. This one should return the name of the file, which is rivers.shp. Then you have describe dot base name, and we can see from our result that we have the base name as rivers. So in a file such as rivers.shp, rivers is the base name. Next we have describe dot name, which works the same way as describe dot file, and it returns the name of the shapefile. Okay, next we can list the feature class, and this will create a list of all of the features that are within our workspace. So create list of features within workspace, and that one will use the list feature class. So let's just create a list. Let's call it fc list for the feature class list, and we have said you're going to use ArcGIS dot list feature class. Feature classes, like that. So this one will list all of the feature classes in general. You can just print the output. Now, to be specific for listing feature classes using a wildcard, for example, you want to list the features that begin with a letter, and that one can be used as asterisk. And then now first you use the letter, for example B, and then asterisk. That's a comment. Then you can use the ones that you can look for the ones that end with B. So you use the asterisk first, then B. Then next you can look for the one that either begins or ends with B. So begin or end with, and that one you use asterisk, the letter, then the asterisk. So let's try that out. For begins with B, we'll just use ArcGIS. So it will be the FC list. Let me just copy the way it is and paste it here, FC list. And now we'll specify here R. So for example, in our files we have buffer. So let's look at the ones that begin with B. It should print out true. So just use B as the parameter, then print. Yeah. Then also we can check the ones that end with B. Let me just copy and paste that also to save time. And then the asterisk first, then the letter. So run that, and we get an empty list. As you can see, there is no shapefile that ends with letter B. Then also the ones that either begin or end with B, so just paste that out and add an asterisk, B, then asterisk. So we have two that begin with B. So others, there are none that end with B. That's okay. We can also be specific according to the shape type, and we can list the features according to the shape type. So according to the shape type. And in this situation, we can either check if it's a point, a polygon, line feature. That's a polyline. So what we'll do is just use ArcGIS, and then you can just leave the first parameter as empty, meaning that it will not filter according to the letter that begins or ends with. Then now the next parameter which it takes in is the shape type or the data type. So let's check if there are points. and which ones are point feature types. So let's run that, and we have the dams as point feature types. You can also check if there are polygons. Just write polygon and then run. You can also check if there are polylines, then run. As you can see, we also have raster data types, and we can list raster data types by using arcpy dot list raster. Then the same way we listed the feature class, we can also use wildcards to filter out or to be specific on each type of features that we want, or raster features that we want. So if you want to find the ones that begin with some letter, you just use again asterisk and then the letter. If you want to find the ones that end with some letter, it's the if you want to find the ones that begin with some letter, you put the letter, maybe B, then the asterisk. To find the ones that end with a letter, you use the asterisk, then B. I hope you are following. Then if you want to find the ones that either end or begin with some letter, use B, use the asterisk, the letter, then asterisk. Remember, B is just an example. You can use the letter that you want to find. You can also filter according to the, if we run this, you'll see arcpy list rasters. This is supposed to be rasters. We'll get an empty list because we don't have any raster in our data. But you can also filter this according to, you can use wildcards to get the list according to the type. Is it a TIFF? So you just add the new argument. So you use maybe .tiff or .img, depending on which one you're looking at. Then you just run that. But for now we don't have any raster, so we're not going to have any output. Then we can also return the object, that is in terms of the strings. And let's just do an example of how we can go about that. Maybe we want to list the field names that are within the rasters. So list field names that are within the feature class or the raster. So let's just create a variable, let's call it field list. Then we'll use arcpy, and we want to list the fields, so you use .list fields. Then you specify the name of the file. We'll just use let's use reverse.shp. Then we can leave the second argument as empty, then the last one as string, and this should return an object. Let's try and run it up. Then now we want to loop through the field list and print out all of the fields. So for field in field list, print, and we want to print the fields. So let's just go to ArcGIS and see the fields that we have in the list of fields that we have in our data in reverse.shp. Let's just drag and drop it into ArcMap, and we'll just open the attribute table. And as you can see, we have a number of fields. We have the length, we have I think we also have the name. So we'll just check the name and the length. Go back to the code and we'll check field. We'll print field.name, and let's just concatenate that. Then plus we want the length also, and we must first convert it to a string. So string, then it's field dot length. You can also do the same with the raster dataset. Next, we are going to be looking at manipulating the spatial data using Python, and we'll be using the data access module in ArcGIS. And ArcGIS has uses the cursors. Cursors, they create a copy of all of the records in order to loop through them or manipulate the records. So there are three types of cursors. There is the search cursor, which is able to access the records for read only. There is the insert cursor, which inserts a new record or a row, and then we have the update cursor, which makes changes, or you can be able to use it to delete a row. So let's try out to use the search cursor, and we'll just see how it works. So search cursor, and this search cursor, we are going to use it to view the rows in a certain feature class of a certain field. So let's just specify search cursor and start. Let's just call it cursor. Then we'll just say ArcGIS dot, remember it uses the data access module, then search cursor. Then now the search cursor takes in a number of parameters, and the first mandatory parameters are it should take in the feature class, and then it should take in the field names. Then there are other optional parameters which I will mention later. So the mandatory parameters are the feature class, so you can use FC for the DAM. Then now we also have the fields. So our DAM, as if you go to ArcMap, it has a county, and it also has the DAM name. So we'll just check the DAM name and where it's located. So we'll have two fields, that is the DAM name, and you have to name it according to the way it's named in the attribute table. And also the county. Then for now let's loop through it. Let's run this. So for cursor, for row in cursor, we are going to print the county and the DAM. So print, we start by the DAM. So DAM, let's use formatting. DAM 0 is located in one county. Then use dot format, and then we need to access the rows. So DAM name will take the first indexing, which is row 0. Then this one will take the second one, which is row 1. Remember, in Python, indexing begins from 0 rather than from 1. So format, then we'll write row with 0, then row 1. Then you can spin that up and see our result. As you can see, DAM, for example, DAM Colea is located in Mauya County, and so on. We can also one thing I'd like to specify is that here we have already created a cursor, and we have used the search cursor, but when using cursors, we need to close or open the locks during the use of the cursor. So at the end of using a cursor, we need to release the lock from a cursor. And to release a lock, we can use either a with statement, or we can use a delete cursor to delete the cursor at the end. So the with statement will remove the lock automatically. Then the delete cursor will remove the lock manually. So let's try out the two options. We can just use a with here. So you'll say, let's use the with one. With ArcGIS dot data access dot search cursor and then the search cursor it takes in FC, then maybe the dam name. Remember to end it with as cursor, because you are assigning it the variable cursor. Then now we can perform our for loop. For row in cursor, we are going to print row 0. So this will release the lock from the cursor, from the database, and if the locks are not released, then it means no one else can access or make any edits to this database. So that's the importance of releasing a lock. Remember, if we try to run this code, this part, and we did not release the lock, if the code does not run into succession, this means that the lock won't be released. But if the code runs successfully, the lock will be released. So we need to just release our lock whether or not the code runs into succession. So let's run. So you can see the list of all the dams, the dam names. You can also use the delete cursor, and we'll use it at the top here. So you just move backwards a little and just use delete cursor, and this will delete the cursor. To run that like that. Next, let's use the insert cursor, and as we had said earlier, the insert cursor is used to insert a new record into a row. So let's create a new one. So this insert cursor. So we'll just create a new cursor, cursor 1, and use ArcGIS dot the data access module dot insert cursor. Then the insert cursor takes in 2 parameters. That's the feature class and also the fields. So you'll just work on the dam name. Now we want to, within a cursor we have a row. So we want to create a new row, and within that row you want to insert a new record. So to create a new row, you just do cursor 1 dot insert row. If you are to create a new empty row, you'll just say cursor 1 dot new row, but you already have whatever we are going to insert into the row. And you're going to insert a dam name. Let us insert Masinga dam, and you're going to check if it exists, and then always remember to release the lock. So we're going to delete that, then run. So this one is supposed to be a list. So let me just fix this error quickly, then you can check out. Let's go to ArcMap and check out if it works successfully. So open attribute table, and you're going to check. As you can see, the Masinga dam has been added, and if you look across, the other fields are left empty, and this is because you had not specified that you are going to insert any records into them. Next, you are going to work with geometry, and just create a new notebook for that. Then let's import ArcGIS, and from ArcGIS import env. Then next, we want to define the workspace. So env.workspace, this is already knowledge that you have, and we'll specify the workspace. Just take it from the one from cursors, and paste it there, and then you can also specify the feature class. So FC, and we'll look at the, let's look at the rivers.shp. Then run that. Next, we are going to look at we'll use the search cursor to look at the geometry, and the geometry is usually related to the shape field in a spatial data set. So if you check in the spatial data set, there is usually a shape field. Now let's use the search cursor to just look through that, and let's create a cursor, and arcpy.dataaccess.search cursor, and then you're going to assign it the feature class. And then also, now here is where we specify we want to check the geometry. Now in checking the geometry, we use tokens. So there are tokens such as shape, art. There is a token such as object ID art, and several other tokens. So the shape art is the one that is used for checking the geometry. Now we can use shape at XY to find the point or the centroid of a polygon, and then we can use the shape at length to find the perimeter or the length of some feature. Then also we can use the shape at area to find the area of a polygon. So now we can just use shape at length to find the length of the river. So run that up. Then now we want to create a for loop. So for row in cursor, we're going to print the row 1, the row 0, sorry, because shape length has the index 0 here. It's the first field that you have supplied. So as you can see, these are all of the lengths. And then we can also check the XY. So let's create a new feature class 1, and that one will be the dams.shp. Let's now check the XY. We just save, we just run this again. Now for row in let's just change this to a new cursor 1 is equals to arcpy.dataaccess.search cursor, and then we give it the feature class 1, and then we want to check the XY, that is the shape, the coordinate shape at XY. Then you can do the for loop again for row in cursor 1, print XY. So we are going to print the row 0 and run that up. So these are all the coordinates, and they're returned in tuple format. This tutorial, it was just a crash course of everything. If you want some shorter tutorials split into topics, you can suggest, but that's it for now. Remember to like this video, share it, and also subscribe. And if you didn't get anything, you can always go back to the beginning and start over. Bye.